to Engineer Dailin Makasaet, and to all of our classmates. A pleasant morning to all of you. First of all, I would like to introduce myself. My name is Jonah Acabo, and my partner is Edmund Clarence Carlos. And for today, we are going to present our research proposal entitled The Proposed River Spillway Flood Indicator for Marikina River. The Philippines is blessed with a large number of rivers, lakes, and streams. Thus, the lack of water has never been a real problem. Where an apparent scarcity exists, the difficulty is traceable to the uneven distribution of rainfall necessary to replenish waters and rivers, lakes, and other bodies of water. The Philippines has a fairly well-defined wet seasons because of the monsoons. Typhoons and thunderstorms often cause flooding in Metro Manila, especially in low-lying areas like Marikina City. The problem could be defined as a combination of natural and man-made disasters. Harm to private and government property, loss of life, loss of livelihood, and disruption of social and economic activities are all negative consequences of flooding. As reported by World Bank Group's 2017, the Philippines ranks third among countries most at risk for disasters, including floods, storms, and earthquakes. In the past 30 years, more than 360 disasters struck the Philippines, with a total death toll of 33,000 people, which affected 120 million people. Typhoons and floods are the most devastating in terms of their economic and social impact. Accounting to 80% of all deaths, 90% of the total number of affected people, and 92% of the total economic impact. The main objective of this case study is to make a flood indicator for Marikina River. Specifically, it aims to respond to the following questions. First is, what are the technical processes to be used in constructing the flood indicator in terms of materials and procedures? Second, what is the level of effectiveness of the flood indicator in terms of functionality, durability, and accuracy? And lastly, what is the significant difference between the river spillway flood indicator and the standard indicator? The findings of this study will be beneficial to the following: to the community of Marikina City, which is usually affected by the river overflow, and having a flood indicator in the spillway of the Marikina River in these communities will alert and warn the citizens. To the local government unit, this device is a tool to lessen the number of possible casualties during river overflowing of the Marikina River, and to the future researchers who will conduct the same and similar study, it will help them to have knowledge and how to build and use it.
In the study of Passy and Babe 2015, it revealed that flood monitoring and evasion system based on WSN continuously monitor, detect, and report the environment status to a control unit using relative water level, thrust, and intensity of water as flood indicators, whose values are gathered by sensors in the sensor field. The Flood Monitoring and Evasion System monitors and computes the status of floods and sends flood notification message to the base station of such zone for necessary action. The system is composed of three major modules, which are the sensor module, observation module, and the transponder module. The developed system is stout, gives well-timed alert of flood occurrences, and controls the floodgates to avoid flood in coastal areas. As studied by Alfaro et al. 2013, improvised flood alarm device is comparable to commercially available devices in terms of providing real-time flood levels alert and sensitivity to water. This early warning flood indicator is one way of saving properties and keeping individuals safe during flood disasters. Household, school, and barangay community frequently affected by coastal floods considered the simplicity and practicality of the equipment designed for future replication and modification. According to Yudo and Isong 2014, nowadays, people need to have a new development of product, model, system, and device to control the flood. Having an upgraded product will help the community to have an accurate signal, to be alert when it comes to flood, and to reduce the risk of losing the loved one. According to Industry et al. 2018, indicated that a flood disaster provides considerable losses to the people who live around the river. To mitigate losses of material due to the flood disaster required an early warning system of flood disaster. For that reason, it's necessary to design a system that provides alert to the people prior to the flood disaster. This device consists of two ultrasonic sensors as a water level detector and the water flow sensor as a water flow velocity sensor. The wireless technology and GSM are used as an information medium. The system is designed based on water level conditions. Characterization of water level detector shown the device effectively works in a range of water level of 14 to 250 cm, with a maximum of relative error of 4.3%. Meanwhile, the wireless works properly as far as 75 meters and the SMS transmission time is 8.20 seconds. The objective of research. First, to make a flood indicator to help the people be warned and alerted. Next, to help the community of Marikina City, which is usually affected by the river overflow. And lastly, to lessen the number of possible casualties during river overflowing of the Marikina River.
The figure below shows the input, process, and output of the proposed river spillway flood indicator for Marikina River. In input, it shows the materials needed in constructing the flood indicator, such as liquid level indicator switch, mini siren, light bulbs, yellow, red, and orange, circuit breaker, and galvanized iron pipe. In process, proposing the flood indicator, conduct a survey, data gathering, data analysis, construction of the device, developing, testing of the output, and lastly, the output, river spillway flood indicator for Marikina River.
In the study of Passy and Bates 2015, it revealed that flood monitoring and evasion system based on WSN continuously monitor, detect, and report the environment status to a control unit using relative water level, thrust, and the intensity of water as flood indicators, whose values are gathered by sensor in the sensor field. The flood monitoring and evasion system monitor and compute the status of floods and sends flood notification message to the base station of such zone for necessary action. The system is composed of three major modules, which are the sensor module, observation module, and the transponder module. The developed system is stout, gives well-timed alert of flood occurrences, and controls the floodgates to avoid flood in coastal area. As studied by Alfaro et al. 2013, improvised flood alarm device is comparable to commercially available devices in terms of providing real-time flood level alerts and sensitivity to water. This early warning flood indicator is one way of saving properties and keeping individuals safe during flood disasters. Household, school, and barangay community frequently affected by coastal floods considered the simplicity and practicality of the equipment designed for the future replication and modification.
There is a significant difference between the proposed river spillway flood indicator and the standard flood indicator.
The researchers went to different internet sites to collect data and to support the study. The researchers will utilize a questionnaire checklist as an instrument for data collection. The survey-type questionnaires will consist questions: what are the technical processes to be used in constructing the flood indicator in terms of its material and procedures? Also, it includes the level of effectiveness of the flood indicator in terms of its functionality, durability, and accuracy. Lastly, to test the significance between the proposed flood indicator in Marikina City and the standard flood indicator, t-test formula will be used.
Here is the proposed river spillway flood indicator for Marikina River. The flood indicator has three warning signals. When the water level reaches 50 centimeters from the base, citizens need to be alert on water overflows. The signal light will be yellow. 100 centimeters from the base, water level is at road level. Light vehicles cannot pass the road. The signal light will be orange. And if 190 centimeters from the base, water level is at the barrier level. Light and heavy vehicles cannot pass the road. The signal light will be red and the siren will automatically be activated. The flood indicator needs a flow of electricity to operate. The researchers use experimental research and also use quantitative method to collect numerical data in order to analyze the data. The proposed river spillway flood indicator for Marikina City used experimental research to prove its effectiveness. The researchers will use t-test hypothesis because the study needs to measure the association between two variables in a quantitative way. This is used to regulate if there is a significant relation between proposed river spillway flood indicator and the standard flood indicator. Recommendations for the future researchers. First is, they may improve the device by making it higher and bigger to be seen by the residents and the motorists from a long distance during bad weather. Second, they may use larger siren to alarm the residents. Third is, they may improve the device by incorporating a wireless sensor network which uses GPRS or SMS whenever flood water is rising. And lastly, they may use solar energy to provide cheaper source of power. That concludes our research presentation. Thank you so much for listening. The researchers are now open for your questions, suggestions, and constructive criticism.